Hey everyone, in this video we will talk about how to simplify radicals. So recall that a radical is an expression that uses a root, such as a square root, and a perfect square is the square of a whole number, which is the product of a number multiplied by itself. So we'll start off pretty easy here, and we have the square root of 121, and the factors of 121 is just 11 multiplied by itself. So the simplified form of the square root of 121 is 11. And now we have the square root of 7. And we know that 7 is prime. So this means it doesn't have any factors. So the square root of 7 is actually already in its simplest form. But they're not all that easy. Sometimes if you don't have the prime numbers or you don't have perfect squares, you have to start out by making a factor tree. So for the square root of 12, we want to find the prime factors. So we can have 3 times 4, and then 3 is prime. So now we take 4, and it's also 2 times 2. So now we have the prime factors for 12. And you can see we have a pair of 2's here, and then we have a leftover 3. And the reason we're looking for pairs is because a perfect square is a number multiplied by itself. So we want to have pairs of our prime factors, and we have that here with 2 and 2. And again, if we multiply that back together, we would get 4, and the square root of 4 is 2. So we're going to take that pair of 2's, and we'll put 2 outside the radical. And this number right here, 3, since we can't break it down any further and it's not a pair, the 3 goes inside because we haven't taken the square root of 3, but we can take the square root of 4, which is what we did here, right here. So the simplified form of square root of 12 is 2 square roots of 3. And now we can try it again with 48. So again, we will make the factor tree, and 48 is 12 times 4, and 12 is 3 times 4, which is 2 times 2, 4, 2 times 2. So now we have 2 pairs of 2 and a leftover 3. So when you have multiple pairs, you can just multiply them together. So on the last question, we said that even if you have a pair of 2's, it is still just a 2 that you bring, because if you multiply these together, you get 4, and the square root of 4 is 2. So here we will have 2 times 2, since this is this 2, this pair is this 2, and then on the outside, on the inside, we'll have the square root of 3 that's left over. So simplified form is 4 square roots of 3. And again, they're not all that easy, so we can go cover the steps again. So we have, first, make a factor tree. Second, identify pairs of factors. 3, identify the leftover factors, which are those without a pair. 4, the pairs of factors go outside the radical, and the leftover factors go inside the radical. And remember, if you have multiple factor pairs, like we did in the previous question, you can multiply them together. And if you have multiple leftover factors, you can also multiply them together, and they just go inside the radical. So take a second and work out this one by yourself, and when you're done, come back and we'll go over it. Okay, now that you are back, we have 72. We can break this down into 12 and 6. 12 is 3 times 4. 4 is 2 times 2. 6 is 3 times 2. So let's circle our pairs. So we have a pair of 2's. We have a pair of 3's. And then we have our leftover 2 here. So remember, we'll take our 2 times 3. Because those are our pairs, they go on the outside, times the square root of 2 goes on the inside, because we do not have a pair for that one. So we'll put this together. 2 times 3 is 6, and the answer is 6 square roots of 2. Okay, take a second and pause and try this on your own. Alright, now that you're back, let's go over the answer. So 45 is 9 times 5. 9 is 3 times 3, and that's as far as you can go because these are all prime. Now you have a pair of 3 and a leftover 5. So the 3 goes on the outside and the 5 goes in the middle.